Okay, class, in this lesson, we are going to learn to use volumes of right and oblique pyramids and cones to solve problems. All right, so let's go ahead and get started. So to find the volume of a pyramid, it is essentially 1/3 the product of the area of the base and the height of the pyramid. And so in other words, the volume of this pyramid is going to be 1/3 times the area of the base times the height. Okay? Volume is equal to 1/3 times the area of the base times the height. And then to find the volume of a cone, the formula is the same in that it's going to be the volume of the base, 1/3 times the area of the base times the height. Okay, so what you'll notice is that whether you're talking about the volume of a cone or the volume of a pyramid, we need to take into account the area of the base, and that's the same in both scenarios. We also need to take into account the height of both figures, and then we take 1/3 of that. Okay, so there's actually a simple way to remember how to calculate the volume of a cone or a pyramid. If you think about the volume of a prism or a cylinder, okay, so if you recall, volume of a prism is equal to the area of the base times the height. Okay, area of the base times the height. Similarly, the volume of a cylinder is also equal to the area of the base times height. Okay, and so when you take into account the volume of a cone or a pyramid, the object essentially all kind of points to an apex. Okay, so for this cone, this all goes to a point. When you have that scenario happening, similarly with the pyramid, see how this goes into a point? Instead of going straight up like a prism, these go to a point. When you have that scenario, you're just going to take 1/3 of the original volume. What I mean original is before it was a prism, okay? And that was equal to the product of the area of the base times height. And now when we take into account the the pyramid, now we have to take 1/3 of that, okay? So simple way to remember it is just take 1/3 when you're talking about a pyramid or a cone, okay? Otherwise, it's just the area of the base times the height. Okay, so let's go ahead and solve the next problem in this example. And so here we have Kyle's truck that can haul 1.75 tons of corn per load, okay? And we're also told that 1 cubic meter of corn weighs 0.8 ton. So the question is, how many loads will Kyle haul to move the pile of corn that is contained in this cone below? Okay, so the first thing we need to do is to find out how much corn can be fit in here. So we need to calculate the volume. Okay, well, the volume of this cone is going to be 1/3 the area of the base times height. Okay, and then the area of the base is circular, so we would have to find the area of this circle, and that's going to be pi r squared. So we can go ahead and rewrite this equation as 1/3 times pi r squared h. Okay, now let's go ahead and substitute some of these variables with the values given. And what we have is this is going to equal 1/3 times pi times the radius Here we're told the diameter is 4 meters, so the radius will be half of that. So that's going to be 2 meters. And that's going to be squared, and then times the height, which is given to us as 1.5 meters. Okay, so if we use 3.14 for pi, then we get a value of, let's go ahead and punch this in the calculator, and we should get a volume, of 6.28, and this is going to be cubic meters, or meters cubed. Okay, all right, so we've found the volume of corn contained in this cone below. Now we have to figure out, can Kyle haul this amount of corn in his truck, which can hold 1.75 tons? Okay, so we need to do a little conversion here, because we're told that 1 cubic meter weighs 0.8 tons. Okay, so 6.28 cubic meters is what we've calculated for the volume of corn, and we're told that 1 cubic meter is the equivalent of 0.8 tons. Okay, so if we multiply this across, what you'll see is this meters cubes cancel out, and 6.28 times 0.8 tons gives us 5, oops, let me change the color here, it's about 5.024 tons. Okay, so now that we've done the conversion, we have to take into account how much Kyle's truck can haul. It's 1.7 tons, okay? And so we need to figure out how many loads that is equivalent to. And so we're going to take 5.024 and divide that by 1.75 tons. And we're going to get 2.87 loads, okay? Or, since we can't do fractional loads, this is going to take 3 loads, okay, for Kyle to haul or move this pile of corn. Okay, 3 loads. Okay, let's go on and move to the next example. So now we have Jason is using this mold pictured below to make 12 candles, and the question is, how many cubic inches of wax will he need to make 12 candles? Okay, so then we need to figure out how much volume this consists of. And so let's go ahead and start with the equation. This is the volume of essentially a pyramid, but upside down. And that's going to be, again, 1/3 times the area of the base times height. Okay, and that's equal to 1/3. The area of the base is this triangle here. Okay, and we're given the height, and we're also given the base of the triangle. We know that the area of a triangle is 1/2 the base times height. Okay, and that's the area of our base of the triangle, and then we have to multiply that by height. So I should probably call this height of the triangle and the base of the triangle, so we don't get our B's and H's mixed up. So now we can go ahead and substitute these values. So we got 1/3 times 1/2. The base of the triangle is 4 times the height of the triangle, that's 3. And then we're going to multiply this whole thing by the height of the pyramid, which is 6. Okay, so if we go ahead and punch that into the calculator, we're going to see that this comes out to 12 cubic inches, okay? So if one mold requires 12 cubic inches and we need to make 12 molds, then we're going to need 144 cubic inches of wax. Okay, so hopefully that makes sense. We've used two different examples to calculate the volume. If any of this didn't make sense or you need to listen to this again, please go back to the beginning of the recording. Thank you very much.